steps equations. Exactly what the name says is how many steps are involved. So a one-step equation. Let's look at 3x equals 12. We're looking to solve for our variable, our unknown. In this case, our variable is x. It could be any letter, doesn't have to be x, but x is most commonly used. So to get x by itself or isolate the variable, we need to get rid of our 3 here. So I look at the operation that's happening between the 3 and the x. 3x is understood to be 3 times x. We just put it as 3x. So to undo multiplication, we have to use division. So I'm going to divide both sides by 3. Cancels out over here. 3 over 3 is a 1, leaving us a 1x, or just x. And 12 over 3 is 4. So I have my answer, x equals 4. We could always take this answer, substitute it back in, or replace the x with the 4 to see if we are correct. 3 times 4, 12. Yes, 12 equals 12. So we are correct. If I had another one-step equation, such as x minus 2 equals 4, I look over here again on my left side, that's where my variable is, and I need to get the variable by itself. Isolate the variable. Here, it's subtracting 2. So the opposite or the inverse operation of subtraction is addition. So I'm going to add 2 to both sides. X equals 6. I could always take the 6, substitute it back in. 6 minus 2 is 4. 4 equals 4. It is done correctly. Two-step equations. So the example here, 2x minus 4 equals, let's do 8. So 2x minus 4 equals 8. I still need to isolate the variable. Here, when we're solving our two-step equations, we have to go in the reverse order of our order of operations. So order of operations, parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. So I want to start with addition and subtraction. So here I do have a subtracted 4. So I have to work here with my subtracted 4. So I'm going to add 4 to both sides. So I'm going to drop down the 2x. Here are the 4's. Negative 4 plus 4 is 0, so it cancels out. 8 plus 4, 12. So I have 2x equals 12. I've added back to a one-step equation, and I need to divide by the 2 to get my x isolated by itself. 12 over 2, 6. I could plug it back in here to check. 2 times 6 is 12. 12 minus 4 is 8. Correct. Our last example is when we have parentheses involved. So if I have 2 times x minus 3 equals, let's put 4 here. I have 2 ways I can solve this. Now, again, if we think of order of operations, parentheses, exponents, multiplication, division left to right, addition and subtraction left to right. We do have a subtracted 3, but it's inside the parentheses, so I can't start there. So I want to start by getting rid of this 2. So I could divide 2 by each side, because again, anything we do to the left, we have to do to the right in all of these equations. If I divide it by 3 in my first example on the left, I have to divide by 3 on the right. So back to here, if I'm dividing by 2, I will get rid of that 2 in front of the parentheses. So now I'm left with x minus 3 equals 2. Because once I get rid of that 2, I could drop those parentheses because now that's all that's left on that left side, the x minus 3. And then it goes back to like example 2 here, one-step equation. We'll add 3. X equals 5. Now, in math, though, there are a lot of ways to solve the same equation. I could have solved this equation by distributing the 2. So if I had 2 times x minus 3 equals 4, I could have taken this 2 and distributed it to each term inside of my parentheses, giving me 2x minus 6 equaling 4. And then I would solve my two-step equation. I could add the 6, 2x is 10, divide by the 2, and x is 5. So just a different way of solving the same equation. Both are acceptable.